Welcome back to the lab again, folks. We've got some more sundry and various stuff for you today. So I'm going to put this in under mailbag because most of the stuff that I have in is kind of new acquisitions, although it didn't all come in the mail. So this did. And I want you to excuse me, folks. The cut of my jib is not that great today. I've been out cutting, splitting, and stacking wood. And I just came in to do this, and I've got to go back out and do it again, so I didn't bother getting changed and just summarily washed myself up. So please excuse me. I don't normally have this kind of grubby attire on. But anyway, let's get into this. This I think is an Alibaba order. Or AliExpress. Seems to be ordering a lot from them lately. And this is very, very mundane. So this is 300 nylon cable ties. Yeah, just a generic supply. I'm not going to bother demonstrating them to you. You all know what cable ties are, right? These are just the really small little ones, for doing internal cabling and stuff like that. So yeah, handy to have about. We'll put a link in the description below. I forgot how much they are, but when I get the link, I guess I'll find out. And you guys can always click on it and see. I think they were cheap. I'm cheap, so if I got it, they're cheap. All right, now here is an interesting little thing. It's a Casa Smart Wi-Fi Plug Mini. These went on sale at on Amazon, really cheap. I think it was $10 Canadian. So I had to get one. Now I do have a Casa plug which I use to turn on and off the light out in my woodshed. But I thought I'd try one internally, and I'm going to put it down here in the lab to turn some equipment on and off remotely. Again, to prevent damage from thunderstorms. So I know if there's going to be a thunderstorm while I'm away, I can get on my phone, shut down the equipment in the lab. So let's have a look at this then. The other plug I have is kind of like an outdoor plug. It's kind of on a little extension, and it's got a couple of outlets on the bottom of it. It's been very handy. So I imagine this is going to be just as handy. Oh, this box is about 75% empty. Got a big compartment underneath for this little piece of paper. Interesting. It comes under the category of waste packaging, I think. Anyway, here it is. I guess that just plugs in somewhere, and well, what are the instructions here? Step 1, download Casa. I already got Casa on my phone. Add to Casa, press the plus button, smart plug light / mini, plug in power up, follow the instructions. Well, yeah, why don't we do that? See how it goes. I need something to plug into it though to see how and if it works. Okay, I've got this this lamp here, this lighted magnifying glass. I'm going to plug that into it to see if it's working. So now I just follow the instructions. I'm plugging it into the power. I've got, okay, so go in, add a device, smart plugs, smart plug mini. I think this one is Wi-Fi, yeah. Next, plug your device in. We'll check your location, blah, blah, blah. So the device is plugged in. Next. Look at your smart plug. Is the Wi-Fi light blinking? It is. Allow location permission when using the app to find or connect your device or use. So we'll allow. Precise. Yeah, this will be probably closest to this. Okay, let me type that in. Okay, give it a device name. Let's call it Lab 1. good enough. All right. This would have to happen, right? Okay, it's finished updating. It seems to be on already. Let's turn it off, turn it on, turn it off. Yep, that works. Awesome. Okay, let's get on to the next thing. All right, next we have these. These are rechargeable 9-volt batteries. I thought I'd pick some of these up and try them out. If the price of 9-volt batteries is quite high, and a cable, no instructions, no information. Okay, so on the side of them, they claim to be 1300 milliamp hours. Of course, they don't give you any specifications of what that really means. Is that, you know, going from the maximum voltage down to what voltage? Like 7 volts, 7.5 volts, 8 volts? Or is it to completely drain the battery of all energy? So, I mean, there's specifications like this, but if they're not fully specified, how do you really know what they mean? So what I'm going to put a couple of these on charge here. Come back, and I've got a little load up here. Actually, I should show you guys something about that load. Maybe that's a future video. But I'll put them on this little load up here, and we'll see how far we get with them. So what I'm willing to sacrifice one of these batteries for the sake of science, and I'll just let the load go until the battery itself says no more. And then we'll see, A, can it be recharged after that, and B, what is the actual milliamp hour rating of it. So let me get these on charge. To take it says here micro USB, and but it's Type C, which I guess is more common these days now. But I guess the tube of heat shrink that they use for covering these things hasn't been updated since they updated the image of the battery. And it seems to be a fairly good make. I mean, they make other kinds of batteries, especially the 18650 cells, and they seem to be highly rated. So let's have a look at how this makes out. So I'm going to put this on charge now. We'll get on with the next thing. Okay, what this here are the cells out of a battery pack from a Lenovo T-Series laptop. Those T-Series laptops are fantastic. I have one myself. This comes from a friend of mine who said he dropped it down a stairwell at a hotel and ended up cracking it. He said it registered as 100% charged on his device, but the device wouldn't use it. And I tried it in my own. I have a T480 from a few years back. It's still a fantastic machine. And it did the same thing. It knew the battery was there, and it said it was 100% charged, but wouldn't use it for some strange reason. So let's have a quick look at these cells here. Let's see what we're getting on them. 4.12. Well, that's a fully charged lithium-ion cell. 4.12. Pretty well 4.12 as well. So yeah, these look like they are fully charged. Now I think this crinkle here is just because they were stuck down on the sticky tape here inside the case. So when I took it apart, they pulled that up a little bit, but I don't think it's going to affect how the batteries work. All right, you know what I'm going to do? I'm going to take one of those off there, and when our other little, like our 9-volt chargeable batteries, rechargeable batteries are finished on the load up there, I'm going to put one of these on it and see what kind of life we get out of these batteries. Some tape holding them together here. These are a nice size cell to fit into a little project. So if I can get some little single cell battery management modules, that'll be ideal. Should I take a closer look under here? I'll probably just use them like this, with these on there like that, unless it's inconvenient. Then I can try and take these non-destructively off the tabs. So see, I don't know if you can see it in there, but there's two metal tabs coming out, kind of covered up with tape and stuff, but these make nice solderable connections. I don't know if those tabs are solderable or if you have to weld them, but that's fine. So look forward to seeing this in a future video, where I go through and you know, cycle the cell to see what kind of capacity it has. Got into doing my own firewood, because the prices around here for, you know, a full cord of wood is ridiculous. And we go through a couple of full cords in a year. That's a temperature sensor there. We go through a couple of cords a year heating the house, and it came out to, it's starting to go up around about $1,200 to heat the house. And then a couple of years ago, $1,200 was fine, but then when the guy dumped the load off to me and he said $1,600, that's when I said, you know what? So the next year, what I did is I went out, I bought myself a really good Husqvarna XP60 something saw. I mean, it's a terrific saw. Like, it's a saw that you would get, you would find in a logger's camp. You know, it costs quite a bit. I think it cost me, back then, it cost me about 900 Canadian dollars. And I also got myself a log splitter, and the log splitter is a 27-ton log splitter, and that cost me about $800 or $900 too back when I bought it. This is going back about 4 years now. And when I think about it, you know, I'll buy a load of wood, and a load of wood lasts me 2 years and it cost me $800. So in the last 4 years, I bought 2 loads of wood for $1,600. And I bought my saw and my log splitter, so it's $3,200. So I've saved $3,200 by doing this little ritual, and it gets me outside in the nice weather. Like, I love this time of year. I love the fall. You can work really hard. It's nice. The air is fresh, no bugs. It's absolutely wonderful. Okay, well, I have you here. I want to give you a little update on the amplifier that I'm refurbishing. This is the schematic of it here. And if you look back at the other 2 videos, you'll see that there was what I thought was first oscillation, then I thought it was crossover distortion. I realized after probing around with it off camera for a little while that it doesn't appear right up to this 3.3 nanofarad capacitor. There's none at all. And then past this, all the way to here, that's where it first appears, in this section here. And I'm thinking to myself, and I'm looking at that, and I thought, oh, well, you know, it's tone control. Why would it do that? You shouldn't be causing any distortion. So I replaced these 2 capacitors, and that didn't seem to make any difference whatsoever. And then I was looking at the circuit, and I'm thinking, well, what is this? Like, I normally think of a tone control as a high-pass filter followed by a low-pass filter with variable frequencies. And I'm looking at this, and that's not that at all. So I stuck a scope on it, and, you know, what I saw was, as you turn this pot up towards that end, this is where that distortion comes in. And then it suddenly dawned on me, okay, you've got this coming in here through this capacitor going in here, and it's a much smaller capacitor. It's got, at this point in time, whatever resistance between here and here, and then down through these capacitors here to ground. I'm not going to try and figure out the complex impedance at this point, but it's driving into some other impedance here. And then you have this one coming down here, feeding in through here. And it's a much bigger capacitor, or through only an 18K resistor. So this here is going to be a much lower frequency. And the phase shift is going to be different. So basically what you're taking is, you know, when you got it down here and there's no distortion whatsoever, you've got just this one coming in here, and basically nothing coming in from up there at all. very little, not enough to provide any distortion. But as you turn this up, you're getting this higher frequency components are coming in more and more at a different phase shift. So they're shifted over by a part of a cycle. That's where the distortion is coming from. It's coming from a really poorly designed tone control. And I can't for the life of me understand why they made the tone control in this fashion. This is just so atypical. Did they do it in order to introduce that distortion to give it a funkier sound? I know either the guys who designed this were dummies, or they're really quite ingenious. Now, when I do the final assembly on this, before I do it, I'm going to hook it all up to one of my fancy 4-channel scopes here, and I'm going to show you all the phase relationships. So I'll hook it up to here, 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 and here, and we'll see all those 4 signals at the same time, and you can see the phase interplay that happens. And that's where that funny distortion, it looks like vertical crossover distortion, is coming from. It's there. Okay, here we have one. It's fully charged. And it's reading 9.09. So that battery didn't go up by very much. Okay. Let's put this one on the little load here. So here's the little load that I have those batteries on, and it's based on this module here. Pretty good little module. As Dave Jones says, it does the business. So look, we've got about 3 hours, a bit more than 3 hours. So we're up to 390 milliamp hours, 2.87 watt hours, and still maintaining 8.99 volts, which is excellent. It hasn't dropped off at all in that length of time. So we know it's at least 300 milliamp hours in those batteries. Okay, so it kicked out at 481 milliamp hours. It's still showing a pretty good charge on it. But we were actually, kind of abusing it. Now, 481 milliamp hours is pretty good. It's about what you get out of an alkaline battery, a really good one. So, yeah, it's not 1300 milliamp hours. But we were drawing a huge load off it. 100 milliamps is a fantastic load for a 9-volt battery. And more typically, you're talking around about 10 milliamps. So I'm gonna put in the other one we fully charged. I'm going to set it at 10 milliamps and see how far we get with it. But I won't be able to report on that in this video. We'll do it in the next video. That's about all I can show you today, guys. Thank you very much for coming out to join me. Hit like, hit subscribe, and we'll see you in the next video. Bye-bye.